Okay, welcome to something completely different. Okay, well, I mean, it's still Python programming, still programming in general. It's just something that we haven't looked at before, and I think it's really, really important that we actually cover at least some of this because it's really, really critical stuff. Let's put this into the correct context. All of the problems you have worked with so far in this course are essentially made up. Oh, wait a minute, so you're just teaching a bunch of stuff that isn't useful? I didn't say it wasn't useful, I'm just saying it was kind of made up. The problems I've been giving are kind of made up because you think about some of the exercises I've given. I mean, you saw the past problem exercises before. I suppose I could have popped one of these things open. In fact, you know what, I might as well do that. So yes, sorry, we'll need that in a few minutes, but let me pull open something just so I can say, hey, look, I mean, this is legit, this is how the problems look, but do they actually look this way for real? Okay, so just give me a second while I find this. Student resources and lab exam past problems. Okay, this way I'm not giving away anything that's top secret. Everybody's got a copy of it. All right, like for example, if you pick something here towards the bottom, like even the library thing is the same. Okay, so here you go. You'd be given a list of sales data where each item in the list is a tuple consisting of a location and a branch of a shop and the second items, blah, 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 blah. Basically what you have is you have a list of tuples and you have to write some kind of a function to do the analysis. All right. The function to do the analysis, that, by the way, is legit. I mean, that's actually a valid use case. Even the shape of the data is, I mean, most people wouldn't keep data in this format, but that's fine. That's where it is. But what do you do when you solve a problem like this? Okay, well, it's pretty simple. I know what you're going to do on the lab exam. You're going to take the example that's right here. You're going to copy and paste it into the interpreter, and then you're going to start writing code to fill out the function to solve the problem. Okay, and you're going to say, yeah, I got the function, you submit it. And that is a legit way of solving problems. In fact, the function that you just wrote is completely legit, but this overall process of just copying and pasting a bunch of data and sticking it into an interpreter, that's, of course, is very different than, say, what you guys did in 1101. In 1101, your process was ask the user to enter sales information for 6 stores, entering the name of the shop and the amount of storage or the amount of sales for that place. And you're dealing more with the user bringing stuff in. Okay? And that's a little bit more realistic because, I mean, nobody's got a dictionary filled with data that give you and say, here you go, here's a bunch of data. So why do we do here? Well, the reason why we do this here is because we're more interested in the functionality and the processing of the actual data structures itself, because that's what the course measures. INFS 1101 is, okay, well, interact with the user. And how come I don't get the user to interact here? Well, it's because that's really not important, because it's not something that I measure in the course. So if I ask you to enter all this information stored into a list, I can't really give too many marks for it, but it would take you a bunch of time. Okay, you see, the issue is that these data structures are not sitting around somewhere. They had to be curated and they had to be put together by, well, me. I'm the one who put these ones together, and or people like me, not always necessarily me, but people pull these things together. But that's not where the data comes from in the first place. Okay, so where does data really come from? Well, data comes usually from a database, or it comes from, say, a spreadsheet, or it comes from somebody typing, but almost never, because the issue is every time you run the program to type the data again. Okay, fine, if you have 5 numbers, it's all right. The library, can you imagine typing the full library every time you want to test your code? Yeah, nobody's going to do that. A much better place would be to take that information and save it somewhere so that you can just load it in one shot. The place where you save it is called a file. Okay, or it's equivalent to actually going to a database. It would give you the same type of information. All right, so that's the whole purpose of the current and really kind of the last section. Really, the only thing we have left is just files, and we got a little bit of exception handling because files tend to generate a lot of exceptions, and I'll show you the mechanism of how to handle them. All right, so that's the whole idea behind a file. So if I remember correctly, I believe that the slides start off, and I can probably stick on the slides for at least 4 or 5 slides, and then we'll go over and we'll do some coding. So we get some ideas how this works, then we'll hit the slides again to make sure that we've covered everything. All right, so here's a problem. Everything that you learned so far is definitely true, and one of the things that I hope that you know by now is that all the variables are kept in RAM, and RAM is a volatile storage mechanism, which means, hey, once your program is finished, all of those values go away. It's kind of like having local variables inside a function. Once the function is finished, everything disappears. And even if you go back to an 1101 type program where you're asking the user to put in their name and so on, well, as soon as you stop the program, start it again, you have to ask the user again for their name because it just doesn't remember anything. So this is the problem, is variables lose their data once the program stops. And of course, well, that would be fine, except think about real programs like Microsoft Word. I mean, we still write things, but can you imagine how irritating it would be if you typed up like 5 pages of report and you closed up Word, and then tomorrow when you want to work on it again, you had to type everything again from scratch? Yeah, it's not going to work this way. But the way how you deal with this is you save your work. Where do you save it? You save it into a file. And then later you open the file and you bring it back into memory and you continue to work. Okay, so a file is simply a storage location somewhere on the computer's disk that, if I suppose the best way to describe it, is survives power outages. In other words, it retains its data until you decide to get rid of it. All right, so our problem now is going to be, well, how do we interact with a file from a Python program? How do we take some information that's in a bunch of variables, save it, and then how do I run a different program and take the data from the file and put it back in so I can start processing again, so that I don't need to try and remember it, and I don't have to do that kind of fake business where I'm giving you like a dictionary full of a bunch of stuff you copy and paste. Okay, and besides, copying and pasting this big library, I hope that you've realized that that's really unpleasant because it makes your program look massive, and it's really just a bunch of data. So yeah, with this, you'd actually be able to take your library and save the library to a file and then read it back in. I'm not going to make you do that, but it would be a really cool exercise. All right, so let's just talk about the concepts first. It's actually pretty straightforward. When we talk about writing data to a file, what we're doing is we're talking about taking values that are inside a Python program, inside variables, and actually writing it onto a hard drive. Okay, which of course will retain all of its information. And reading data from a file means to take the data from a file and bring it and put it back into a Python variable. Okay, so pretty straightforward. Writing means to put, and reading means to take from the file, bring it back into your Python program so that you can maybe do some analysis on it. Okay, and we'll try to convert some exercises before we go today. All right, so we got one extra thing. I guess there's 2 more slides because you can see the next one also contains the same thing. How do you process a file? Okay, so this is before we get into the world of Python. So the following is true no matter what programming language you ever deal with. All right, so what I've done is I brought a file. Okay, this is a folder. Okay, fine. I mean, what do you put inside? Well, you put information. The stuff that goes inside is actually the files. So we're going to pretend that this is a file. Okay, so forget anything about a folder. All right, if you want to read or write data, well, where's the data kept? Well, the data's not kept out here. The data is kept inside here. Okay. Step number 1, for you to look at the data, well, looking at it this way, you can't see it. You'd have to, first of all, open it. Okay, that's the first thing. Now, once you open it, now you can read or write the data. So reading, of course, means to go through and say, okay, the following information is here, and you're telling somebody. That would be reading the file, or perhaps you grab a pen and you write some new information. And what do you do at the end? Well, you close the file, because if you leave the file open, sometimes like some stuff could fall out. You might get damaged. Does that happen inside a computer? Sort of. There is kind of the small possibility of this, and we'll talk about this. I think it's on the next slide. If not, then we'll bump into it a little bit later. All right, so right here, before you can use a file, you have to open it. And when you open it, you have to tell the computer, and this is always the case, this is the operating system's restriction, by the way, is you first of all say, hey, I want to open up a file. The first thing it needs to know is which file. Because guess what? Your computer's going to have like hundreds of files. I mean, even if you only have one, there's going to be hundreds of files. So you have to say, yeah, I want the yellow file or the file with a certain name. When you open this up, you have to tell the operating system in advance, I would like to open this, and please get ready for me to look at the information but not change it. That's called reading. Okay, the other option is to, oh, well, I want to look and see what's in, or sorry, I'm going to open up the file and I'd like to put more information here. You have to specify that when you open the file. Or perhaps you'd like to be able to open it up and you want to read some information and add some more information at the bottom. That's opening for both reading and writing. So if you don't plan to write to the file, generally what you do is you open it up as read. Okay, so why do they make the difference? It has to do with the way how operating systems work. I won't say this is exactly 100% accurate, but it'll give you some ideas about why do they have it for opening, reading, and writing. If you open it up and you say, hey, I want to look at the file, and then suddenly you start taking a pen and start scribbling over top of it, that's probably not any good. Okay, so imagine if this is your transcript and you say, I just want to see my transcript, and you open up for the student, they start crossing out numbers. That's obviously you're breaking the rules in this case. That's the reason why you actually have to specify what would you like to do. And if you plan on writing to it, the operating system might have to prepare something in order to make the writing possible. So you have to tell the operating system. So sorry, it's the OS who's responsible for this. When you're finished when you're finished working with the file should generally be closed. Usually if you forget to close the file, the operating system says, okay, they forgot to get rid of this. It's kind of like what would happen if you go into a classroom, you log in, and you walk away. Eventually the instructor will come along to log you out. It's kind of the same idea, but when you're dealing with reading for files, what will happen is the operating system, if it sees your program goes away, it'll say, oh, they forgot to close, and they'll close it for you. Unfortunately, when you're writing a file, you might actually not see anything. It just might not work. It unfortunately becomes very, very OS dependent. But the easy rule of thumb is before writing, open the file. After you're finished with the file, close it. You're done, okay? So don't say, well, I didn't think I had to close it. No, just close up and forget it. Okay, let me get rid of my school workbench is always digging for my attention this time of day when I start these lectures, so it's gone. Okay, I just want to see what's over here. Ooh, okay, so I've got a small program. Okay, here we go. Let me copy and paste this program, and let's paste it into the environment. Oh, I'm going to do something completely different today. I'm not going to use this one. Not because it doesn't support things about files. In fact, as you've noticed, you've probably seen this little orange button down here called File Manager. Yeah, we support it. It was really kind of something that we tossed in for the purpose of testing. Okay, it really wasn't meant for sort of day-to-day use. It's got some limitations on it. And I find that when I'm covering files for the first day, I find it's actually easier to explain this using idle. So I'm going to use this for the day. It doesn't mean that you have to use it, but it will make one or two things sort of stand out, and maybe you'll remember as a result. So, sorry, something completely different, which is I will use this one. All right, so I'm going to make a new file. Sorry, it's going over to the wrong place, and we're probably going to have this happen a bunch of times. And here we go, got a little program. Okay, so what's the program about? All right, the program has a list of students. Each student is a dictionary. Oh, and inside, inside the dictionary we have names, we have assignments, which happens to be a list, and an exam. Oh, perfect, this is really nice. This is like a very complicated nested data structure. This works really well for like practice for lab exams, so this is really well timed. All right, and you can see what we're doing is we're saying, okay, go off and do a grade summary, and then I'm going through and I'm printing. If I had to look at what the grade summary is doing, it appears to be computing, let's see, grabs the name, the average, which is the sum of the assignments divided by the number of assignments, and it's creating something about the average assignment and the exam mark, and is printing this. Okay, yeah, it's summarizing some data. So it's taking a list of dictionaries and it's returning a dictionary at the end. Let's see what it looks like, assuming that there's no issue. Now, the first thing that I need to do is before you can run this program, so I know you're going to have to think back to 1101, if I try to run a program, the first thing it's going to ask me is, would you like to save this program? And currently, you can see that this is an untitled program. I've never saved it because I just made it. So first thing I'm going to do is I'm going to hit a Control S. Well, okay, you know what? I'll do the same thing here. That's the same as Command S. All right, and it asks me, what would you like to call it? Okay, so you give it a name. Okay, maybe grade stuff, okay, .py. Okay, well, whatever, I don't even care what it's called. All right, so some grading stuff. Another thing that's really, really important, however, is where am I putting it? Because you don't just save files, because you have to think, your hard drive, how many files can you have on your hard drive? You can actually have a lot. You can have like millions and millions of files on your hard drive, and you're going to have to keep things straight. The usual way how you keep things organized is you have folders. Like, for example, I got a folder in here called courses. Inside courses, I've got 2021, 2022, 2023, 2024, 2025. Inside each of those folders, I've got fall, spring, and winter. Inside each of those, I've got a folder for the individual courses I'm teaching. And then within there, I've got folders for exams and tests and so on. This is the way how we organize things. It's a nice hierarchical structure. It's not good enough just to say, yeah, I'll just save it wherever. No, I'm going to put this in a well-known place. I mean, you can put it wherever you want, but I need to put it somewhere where I'm going to be able to find it, because we need to do a bunch of examples. All right, the place that I put these things in when I'm doing these demos is I keep a folder over here inside downloads. Terrible way. I mean, there's probably better places I could put it, but this is the process that I've got. I've got a folder in here called grading, and what I do is I download like everything that I need that I'm grading. Like, for example, and sometimes I use it for demos, like if I'm grading a bunch of labs, I'll download it and throw it in here. This way I can quickly find it because I just click on downloads. All right, and I've got a folder in here I made earlier called infs1201. Okay, nothing else. So that's where I'm putting this. It's called grade stuff, saved. Okay, done. Now, so sorry, if you're not on a Mac, yeah, it'll look slightly different, okay? But the concept in Windows will look exactly the same. Second thing I want to do here is I want to open up, well, on Mac we call it a Finder. In the world of Windows, it's called Windows Explorer. Sometimes you might call it My Computer. It's, you click on this, you see all the files. That's exactly what I want to show, is I want to show all the files. All right, inside my grading, which is inside downloads, I've got this folder called infs1201, and there is my grade stuff. Sorry for the really small font. I won't be able to make that any bigger, but if I really need to, I can zoom in this way. All right, so here we go. That's my grade stuff. Now, I've put it there because I want to know where it is. This is going to become an important thing in a few minutes when we start dealing with files. So I will keep this available. Okay, and we're going to go over to here. I've saved the file, so at this point right here, what I'm going to do is I'm going to run the program. Bang, there you go. There's the analysis. So what it's done is it has returned all of this information, which is now, let's see, what have we got? What am I printing? I'm printing the student name, and I'm printing the student's assignment average. Obviously, I could print other things, but these were the things that I wanted to print. All right, so there you go. That is that's the output that we're generating. Okay. All right, so that's infs1201 up to this point. Okay, so there's nothing new yet. Now, what I need to do is I would now like to start making this a little bit more file-like. Okay, and let's see what we can do. Like maybe, I mean, why do you run programs like this to calculate averages of students? Sometimes you might need like final grades to be calculated. Maybe you're just doing an analysis to find out, is there somebody who's doing really well, somebody who's doing really poorly? I suppose I should have had like a bunch of low scores in here. And maybe you've got to send this off to somebody saying, hey, take a look at this. I think we need to do something with this student because they're currently failing. Here, everybody's doing really well. It seems like unrealistic data, but anyway, it's data. All right, so if you want to send some data to somebody else, one of the easiest things that you can do is you send an email and you attach the information as a file. Now, what this requires, it requires that the information not show up here, but actually show up as a file. Okay. Now, I suppose one thing that I could do is I could send the entire Python program and let the other person run it. But if the other person doesn't have a Python interpreter, well, then they have no choice. They'd have to maybe do some calculations by hand. So I'm talking about getting this information right here sent to another person, and I don't mean by copying and pasting, I mean sending as a file. Well, how come we don't want to copy and paste? If you have 5 or 6 lines, it's okay. If you have a couple million lines, copying and pasting a couple million lines, it may be physically possible, but it's pretty pretty painful. Try it sometime and you'll see what I mean, because you have to somehow or another grab everything. And Control A doesn't always work, especially if the size gets really big. All right, so what we want to do is we want to get this put into a file. Now, I suppose your first option, because you guys are doing this in the assignment, I could copy and paste this, open it up in a notepad, paste it, save it. Okay, well, let's remove the copying and pasting in a notepad and go directly to a file. Okay, so this is what we're looking at for today. All right, so how do we do this type of thing? Okay, well, we need to learn some new things. Now, the good news about this is it's not really difficult. Okay, honestly, it's not very difficult, but of course it's new. All right, you see, the problem that I have at the moment is the reason why I see it over here is because of this print statement. And this is not meant to be a trick question. I mean, when you call print, what is that? Well, that's an output statement, and it causes output, of course, is something that we're showing to the user. And in the case of idle, it shows up over here in what they call the shell. In the case of our little online interpreter, it showed up in the right-hand window. Again, that's just to kind of simulate this whole idea. And depending on your development environment, maybe things show up in different places. All right, so we're not talking about sending it out to a print, but we're talking about doing output, which, by the way, is sending it to a file. But of course, we don't want to see it here. We want the output to appear in a file. Okay, so how do we do it? Well, remember the steps. Okay, so obviously the function is left alone. We leave the function, it still does the same stuff. This is why we learned all this stuff is, yeah, we're gonna take the data, we're gonna do some analysis, we're gonna return a summary of data. Okay, done. Here's what we're gonna do. If we want to send the output instead of to the screen, but we wanna send it to a file, we need to do three things. The very first thing, you have to open up the file so you can actually write to it. All right, so ready for this? The command to open a file is called open. Yeah, there we go. That was pretty tough, wasn't it? Guess what? Oh, the command to close a file is called, yeah, okay, good. That's at least nice. So it's not like I have to learn new vocabulary. Unfortunately, it's not quite this simple, but it is actually pretty close. Okay, so literally, we're going to open the file, and instead of printing it, I'm going to say send to file. Okay, this doesn't work, but this is the process. Yeah.
Why is the open showed as a purple?
Yeah, why is purple and why? That's because close isn't actually defined yet. Neither is send to file, but the function called open really is the word open. So right now we're just looking for the concept. So open the file, write the data. So open the file, create the summary. Actually, you can create the summary beforehand. It doesn't matter. But I'm going to open the file, I'm going to generate the summary, and I'm going to go through each of the summary, and instead of printing it, I'm going to send it to a file. And when I'm finished, I'm going to close the file. Okay, that's the overall process, what I'm trying to get done here. Now we need, unfortunately, the details about how it's going to work. All right, first thing up, you can't just open a file. What file? You have to give it a name. Okay, you have to give it a name. So maybe the name is called the assignment summary. Oh, and in the world of, I mean, I don't really need it, but we've been using these things for a very, very long time. They're called file extensions, and what they are, these are the things that show up after the decimal point inside a file name. And it's usually used by the operating system to associate files with applications. Like, for example, if you double-click on a TXT file, it opens up Notepad. If you click on a docx file, it opens up Word. If you double click on a PDF, it opens up PDF Viewer. If you double click on a PY file, it tries to run it. Okay? And it says, oh, it must be a Python program, and it runs it. So I'm going to use TXT. That's going to be, for the most part, the file format that we use here, but I will talk about a couple of others. All right, so first of all, I need to say which file. In other words, this is where I want to put the information. It's going to be inside this file. The second thing that I need to provide, so there are two things. One is which file. The second thing is called the file mode. Would you like to read it? Would you like to write it? Would you like to do both? Okay. In this case, the only thing I'm interested in doing is writing information. So The abbreviation for writing is W. Okay, also not bad. Oh, if I wanted to look and see what's inside the file, I would read it. And guess which letter you use? R. Yeah, okay, so not yet, because we don't have a file yet. We'll have to make one. All right, so this is what we're going to do. We're going to open up the following file. Okay, I'm not quite there, but I'm actually really close now. Okay, and I promise we're really quite close to this. Okay, the function to open a file really is called open. And the one to close is actually called close. It's just I'm not calling the function quite the right way yet. When you open up a file, you get back a value. It actually returns something. What you get back is you get back something called a file handle. Okay, it's a term, it's a file. Okay, officially it's a file handle. All right, so here's what you do. If you want to open up a file, you say open, you give the name of the file, and if you're going to put data into it, you put W, and it gives you back a variable. You can call it whatever you want. You can call it blah, but that's not going to be helpful. You can call it X, also not helpful, but data file works perfectly fine. Maybe you could call it the summary file, okay, whatever it is that you want. All right, that's how you open a file. Okay, we can fix that one. I think closing a file is pretty simple. Okay, I think everybody will understand. Okay, yeah, when you're finished, you close the file. You need to say which file you're going to close. I wish it looked like this. I wish it was like this because that would be at least sort of compatible or very similar to the first one, but this is not the way that they've done it. The way that they've done it is you take the file and you stick it in front. So data file dot close. It actually turns out it's a method, okay, rather than a function on its own. All right, but we've seen this before because we've been using list.append and so on, so it's not really weird. All right, so we open the file, we generate the summary. Oh, but how do you send something to a file? Okay, unfortunately, sending something to a file is a little bit different. The first part is not bad. Okay, when you want to put something into a file, it's called writing. So what you need to do is you need to say, well, this is the file that I would like to write. Okay, there you go. So yeah, write the following information to the file. Unfortunately, if I try running this program right now, this is going to fail. I won't say fail spectacularly. Actually, I guess it will fail spectacularly. But it's going to complain immediately and says, yeah, I don't have a write function that takes a string and a string. Unfortunately, here's the problem with the write operation. The write operation takes exactly one string, and I'm trying to print out two strings. All right, let me make this really simple right now, and we will bring this back in a few minutes. Okay, so there you go. There's one string, because student is actually a string. Okay, hopefully it is. All right, and I'm going to write out the name of the student, and I'm going to write out all the names of the students in the summary, and then I'm going to close the file, and then my program is finished. Okay, open the file, write the data, close the file. All right. Now, it's like one of these things. I feel like a magician at some points. Okay, how many files do you see in this folder? You only see one. It's the Python file. All right, let's go over to here. I will save it. There's still only going to be one. I am now going to pull this down. I'm going to say go and run the module. Did it run? Yeah, but I didn't see anything. Yeah, of course you didn't see anything. The reason why we didn't see anything is how many print statements were here? Yeah, nothing. So it makes sense that I didn't see anything. Sometimes what people will do when they're writing to a file is they will say, I'm writing to the file, so at least you let the user know what happened. But what should have happened is over here, there is suddenly a new file called assignment summary. All right, and you'll notice where it went. It went exactly in the same location as the Python file. That's actually important. This you will not quite understand or grasp if you just use the online interpreter. Yeah. It's going to a file instead. That's exactly it. Okay, now, can we see what's inside? No, of course it is. If I double click on this txt file, it's going to open it up in a notepad. Now, sorry, this keeps opening up in the other window, but there you go. And I'm going to zoom in, and, well, there you go. Oh. Okay. Do you see the information? Yeah, of course we see the information. Maybe you don't like it because it put everybody on the same line. Okay, that's kind of gross. Okay, well, in that case, Let's fix it. Okay, so here's what I'm going to do. First one up. We'll come back and we'll try this in a few seconds. So let me just delete that one. Okay, was that absolutely necessary? We'll talk about it. All right, you see, the problem is that when you write a string, it goes to the output. And then you wrote another string, and then another string, and another string, and another string. You see, we've been very, very lucky because the word print, once you print something, it goes to the next line automatically. Writes, this doesn't happen. If you want something to go to the next line, this is your problem. So if you want the output, if you want each student to be on a line by itself, this is what you're going to do. You're going to have to do your own new line character. So please put the student plus the new line character. Okay, let me save it. And, okay. Let me just stick a print statement over here, and I'm going to, I'm not going to put it here. I'm going to put it over here saying data was written. Okay, and remember, that is going to show up in the file or on the, in my shell. Yeah, in the shell. The other stuff that writes, that's going to go to the file. Okay, so let's run this one. Bang, data was written. I mean, I don't know if it was. I mean, you could say anything. But let's pop over here. You'll see that my file has returned. Okay, and I will double click and open it up. And sorry, it's gone over here again. And maybe that's a little bit nicer. Okay, yeah, this is getting there. This is the type of thing we're looking for. All right, so this time we ended up with different things, or different students on each line. So we just included the new line character. Yeah. I have a list that's wide. Horizontal, you print it out one item at a time. Okay. Hey, no problem. Hey, no problem at all. Let me do it this way. Yeah, just use a for loop. But of course, remember to put a new line character each time. Okay, do you want me to continue with this? Actually, you know what, I want to. Okay, I want to because it's actually a really cool idea. Let's just have some data, okay? Because I got a couple of questions I need to ask. All right, here's what I want to do. Let me steal a little bit of code. Yeah, that's exactly it. Okay, I'm going to open up the file. I'm going to say for D in data. I doesn't work because it's not I, it's data. If these were test scores, then you'd use T or test or something. All right, and of course, I'm not interested in doing print. I'm interested in sending to the file. So to my data file. Oh, can I have two files open at the same time? Yeah, no trouble. You can have as many things as you want. The operation is called write. All right. Write D? Yeah, because if you want it on a separate line, you're gonna have to remember to do this. All right, at the very end, we're gonna say data file dot close. All right, and then I won't do anything else. All right, now I have done this for a particularly important reason. All right, here we go. When I run this, okay, let me close up this one so we don't get confused about anything. In fact, let me close up all of these other windows to make sure I don't have any. Okay, all my text editors are closed. All right, when I run this, I am going to, at least we think, this is going to write the numbers 3, 5, 4, 6 to a file on a separate line. Okay, now I've got a bit of a question here now, and we can try this as let's predict what's going to happen, and then we can see what happens, and I can explain. I already have a file with the same name. Okay, and if you remember, what I've got is I got those names of the students. Okay, now my question is, before we go and run it, if I open up the file, assignment summaries, the same file name for writing, and I write 3, 5, 4, 6, there are a few different options that may happen. What do you think some of those options might be? In other words, what's your prediction for what's going to happen? When I open up this file afterwards, or assuming, if I open up this file afterwards, what am I going to see? All right, so what's your prediction before I run it? 3, 4, 5, 6. What about the students that were there before? Because remember, I've already got a file filled with students. Will we see just the numbers? Will we see just the students? Will we see the students and the numbers?
Only the students, because we only open and close.
Okay, so there's a prediction. Okay, any other prediction? Sorry? Both of them. Okay, that's a reasonable expectation too. And only the other. Okay, good. We have all three. So everybody thinks that something is going to happen. All right. Well, the good thing about this is it's very, very predictable about what is about to happen. So it will always be like this. So it's not going to be random. It won't be one way one time and one way a different way the next time. You know, one thing that nobody did say is, well, maybe it's an error. Because if I was going to give a multiple choice question, I would then stick, oh, one of your options is only the numbers, only the students, both the numbers and the students, and error because the file already exists. Honestly, I would give that as an option. All right, so there's the 4. And as soon as I start presenting errors as options, everybody says, yeah, it must be that. Okay, don't, and I'm not saying that it never is, but just be careful because it might not be. Okay, there we go. It ran. Ooh, I got a problem. Okay, good. So there's an error. Yeah, but not quite the error we're looking for. Unsupported operand types for plus, int, and string on line number 28. Now, unfortunately, I've got the line number switched off, and for me to switch this on, I don't know settings if I can find where I put it. Shall add Windows. I know that there's an option in here. It's not something I use very often. Shell and editor, show line numbers in new windows. Unfortunately, I have to close this and reopen it again to get my numbers back. Okay, in any case, it is this line right here. That's line number 28. Okay, because take a look at D. What type is D? That you're supposed to know. It's an integer. Can you take an integer and add a string to it? And the answer is no, you can't. In order for this to work, you have two options. You can either typecast a D over to a string, or perhaps you could do this. You could use an F string. Sorry, let me type it here. F string, and then I could use D followed immediately by a new line character. Okay, both of those work. Okay, all right, so this solves my first set of problems. That wasn't actually supposed to happen. That was just a realization. Unfortunately, we forgot about this one. All right, let's give it a shot again. Okay, run the program. Okay, no error this time. So that option of the fourth one, which says that there's going to be an error, that's going to be an issue. And no, I wouldn't put a question where like, haha, I tricked you and you forgot to convert from int to string. Those are the things you run into when you program. All right, so something has happened, but now what exactly has happened? So we're now down to one of three scenarios. We've got a file called assignment summary. It was last updated at 2:38, which of course was like the last couple of seconds. And when I open this up, it's obviously going to contain something, and the question becomes, what does it contain? All right. Oh, hey, it opened up in the same place. That's useful. There you go. That's what it contains. Just the numbers. Okay, so if you made that prediction, you're correct. If you made the prediction that it was going to show only the students because that was there, no, that's not how this works. The operation when you open up a file for writing is very, very harsh. What it does is it erases everything else, and then whatever you put in gets replaced. Okay, so it basically erases the previous file, and you basically start from scratch. Okay, so hey, I wanted to cover that because it was good, as you say, somebody asked, sort of for unrelated reasons, but it was really, really useful because it gave me a chance to talk about something. Let's go back to this one. Okay, so based on this information, I'll comment the other one out because I might need it yet, and I'm going to ask the question, if I run this one, what am I going to see after I run it? Will we see students, or will we see the numbers, or will we see both? Yeah, you'll see the students because now the run operation will get rid of everything. Now, here's a bit of an issue. Okay, let me save this first. Okay, file is being saved. I'm going to hit a run, and the data was written. Now immediately take a look. You see I left the assignment editor open, and it still says 3456 or 3546. I should have written a 3456. But I still see it. Oh, something is wrong. It didn't work. I mean, it's now inconsistent. Yeah, something very, very important you have to know about files. A lot of editors, especially things like Notepad and so on, you can't leave them open while you're updating from another program. You might have to close it and reopen. Okay, and there's the actual thing. So just make sure to close it, reopen it. Depending on the editor that you're using, sometimes it will automatically update, but mine doesn't. Notepad will also not do this, I think, in Windows. Okay. All right, so there we are back. Okay, well, hey, let's go a little bit further because we had to get back to the grade summary. All right, so let's do it this way. Let's do an F string, and we will print out the student, followed by, I don't know, just for fun, an arrow, followed by, let's see, the summary, summary at student at assignment average. Okay, followed by a new line character. Oh, sorry, followed by this one. Ooh, okay, so here we go. And this one should hopefully get me into the correct format. Bang, data was written. And if I pop this open, okay, well now we're getting something that looks like this. Okay, and whatever format it is that you want to put. Okay, and there's lots of really interesting formats that we will talk about as we go. There's a very, very popular one that we'll see next class. Okay, so let's keep going. Ooh. Okay, so maybe there's one of these things where I've already done it. So the first example was reading some data. Whoops. Oh, yeah. Okay, I just showed you how to write data. Okay, pretty simple. Now, what about reading some data? Okay, so think about the problem here. Think about the issue from INFS 1101. I mean, this is a very, very typical INFS 1101 problem. Here's how the problem would appear in INFS 1101. Ask the user to enter the number of assessments, and then ask that many times for data, for the test scores, calculate the average, and then print it. Okay, so student does this, they make a mistake, they run the program again, what numbers they put in? 85, 90, 95, 92. They make another mistake because, trust me, it happens all the time. And you run the program again, you type the same 5 numbers over and over and over and over again. I'm assuming that you got tired of that. In fact, you saw how tired I am of it. I'm not even taking the course. I'm so tired of it that when I get you to work on code in this class, I just copy and paste the entire data structure in place and say, here, just read it from here. However, we need to go from sort of an unrealistic thing to something more realistic. Let's do something completely different with this reading of the data. In other words, I don't want the data to have the typed by the user. I want the data to come from the file. To begin with, because I think it's what somebody's described as like, did you notice, by the way, that this program was really not that much different, except exactly as somebody said, oh, it's going there instead of here. That's exactly it. Yeah.
So just one thing I wanted to ask.
Sure.
Remember, you see in the line before the last one?
The line before the last one. So this one here or this one here?
This one.
Okay.
What does and mean?
New line character. Go to the next line. Okay. If you leave out that new line character, remember I had to put one here as well. If you leave this out, everything's going to go across in a single line.
You can only do this in a file or can you do this in LSS? What exactly?
You can always do this inside when you're printing things.
So this is another option for either by using the program, right?
Yeah, I don't like to say that one. Okay, like for example, if I had hello done, okay, and I print str, that would show up as one single line, okay, but if you were to stick in a \n, okay, remember this would be hello on one line, done on the next. Okay, so whenever you run across one of these new line characters, it goes down to the next line. All right, let's write the program. INFS 1101, okay, here we go. Let's ask the user for the number of tests. Okay, num tests is equal to int. Okay, input, enter number of tests. Okay, there we go. There's the first one. And now you may say for t in range, let's see, range num tests. There we go. And what I'm going to have is a test score is int input enter test score. Okay, and hey, let's calculate the average. Okay, so I'd probably have a total equal to 0. And every time I entered this, I would say, okay, oh, yes, thank you for reminding me. I would probably say total is equal to the total plus the test score, and soccer, that's different, score. And at the very end, I'd probably have like some kind of an average, which would be the total divided by the number of tests, and then I would print something like the average test score was AVG. All right, there we go. We'll do a quick little test to make sure I don't have any issues with it. Okay, so, all right, program's running. Okay, 4 tests. Sorry, that's let me clear this one up, okay? Sometimes I have some issues with this, with idle. I actually don't use it that frequently. Okay, let's see if we still have this weird thing. Okay, here we go. Popped up in the other one. Okay, there will be 4 tests. Okay, now it's more sensible. All right, so enter the test scores. Okay, if I'm calculating an average, this is the first thing that I do. I put the same score every time, because what's the average? If it's not 70, then we got ourselves a problem. All right, I will probably run it again, and I will just put mostly 70, so 70, 70, 70, and 80. No, you don't need, I mean, grab a calculator, work it out. But if this is working correctly, the average should be just a little above 70, but it wouldn't be quite 80 because there are 3 people holding it down. So like 73. Oh, sorry, and another 70. 70 tests. I'm going to be at this for a long time. All right, sorry, wrong thing. Let me cancel this. I'm sure you don't want me to type in 70 of these. Sorry, forgot the first one was number of tests. Let's try that again as 4. Okay, here's 70, 70, 70, and 80. I'm expecting like 73. Okay, yeah, that's fine, 72.5. All right, so the program is working. All right, good, we're done. Okay, yeah, it's 11:01, we're finished. What I'm interested in doing this time is instead of keeping this information and having to type it in each time, I would rather take that set of test scores and put it into a file so that I don't have to type every time. All right, well, in order to put something into a file, you need a file editor. Oh, congratulations, I got a file editor right here. What do I need to put inside? Well, let's put in a 4. Let's put in the 85, the 90, the 95, and the 92. Okay, here we go. And what I'm going to do is I'm going to say, let's save this. Bang. Although, unfortunately, it's saved inside a file called assignment summary. Do you think that's assignment summaries? Nah, bad name for it. What would you call it instead? Test data? Test scores? Test scores is okay. And I'm going to leave it as txt. Okay, I'll even close up this file, and that's where my information is going to be kept. Okay, so that's where the file is going to, or sorry, where the information is going to be kept. All right, so now what we need to do is we need to somehow or another get some information out of here. Okay, now I have to see what I actually stuck in here in my next slides because I don't want to go and do something completely different than what's on here. When it comes to reading and writing files, there's actually more than one way of doing the same thing. That's why I wanted to check this. It's because this is likely what I would have done. All right, so here's what I want to do. I want to convert this over to a file. In other words, I don't want to ask the user how many tests there are. I want the information to come from a file. Okay, well, you know what I've often done in this course is I quite often start with very, very simple things just to work through to see how things are going. I'm going to do exactly the same thing as here. I'm just going to comment everything out, and I'm just going to do a simple, I want to make sure the program is working. Okay, and we'll build up the program one piece at a time so it makes some sense. Yay. All right. All right, the data comes from a file. Okay, good, it's in the file. What's the first thing I need to do? Yeah, open the file, okay. We know how to do this already. And we know that it needs to be put into some kind of a some kind of a variable. So I'm going to call it the score file. Again, you can call it whatever you want. The command to open a file is called open. I have to provide the name of the file. All right, what did we call the name of the file? We called it testscores.txt. Testscores.txt. We're not interested in writing it because if I open it this way, what happens to my test scores? They're erased. Because when you open a file for writing, it just blows everything away. We're not interested in writing, we're interested in opening it for reading. Okay. At the very end, we're supposed to do a score file .close to close it up at the end. We're supposed to do it. All right. Well, now the question becomes okay, how do I get data? All right. Unfortunately, there's a couple of different ways how to deal with this. Okay. If I open up the file, what's the very first thing? What's the first thing I put inside my file? Yeah, it was number 4. What did it represent? Yeah, the number of tests. Num tests. Okay, we need to get the data from a file. How do you get something from a file? Well, remember what it was. We would have had like scorefile.write. Okay, so what do you think? Read. Okay, yeah, it sort of works. I'm actually going to be a little bit more precise about this, and I'm going to say read line. Because what I want is I want to read the entire line. So this is what I'm going to do. And all that I'm going to do right now is I'm just going to print num tests. All right, and then program is finished. All right, if this works, what number should I see? 4. Okay, that's what I should see. So let's give it a shot. Okay, we run it, and bang, look at that. Blah to say the program started, and 4. Excellent. We're partway there. Almost. Here's a bit of a realization of something. Sorry, I'm going to do one extra thing. I'm going to print the type of num of tests. Okay, and let me run this again. Okay, so what type is, yeah, it's a string. Here's a problem. Okay, everything that you write to a file, at least to a text file, is a string. Everything you read from a file is a string. So it's just like the input command. What do you need to do with this? You need to do casting exactly the same way. So remember, you almost never see just the word input. If you're asking for an integer, you almost always wrap this in a typecast function called int. Yeah, you have to do the same thing here. Okay. So what I'm going to do is exactly the same. I'm going to wrap this in an int. Okay. Oh, we don't tell the file this is what we want. All I'm doing is say, just please read the first line and save it in a variable. So we'll go ahead and run it and take a look. We now have 4. And more importantly, it's an integer. Yeah, so it's the same as a prompt function. All right, so here we go. Now we've got this set up. What do we do next? We're getting really close. And now I think what I will do is I will steal some of this work. So I'm going to grab this, and I'm going to get rid of these, and I'm going to get rid of my comments. Okay. All right, so num tests, that works. Oh, but do I ask the user to enter the test score? No. I go to the file and I say, please give me the next line. And it turns out it's actually really simple. Instead of being an input, all I do is I go back to the score file and I say, okay, read another line. All right, just keep reading another line and another line and another line, keep adding it. And when you're finished reading all the files, we'll close up the file. And then, of course, well, we want to do these 2 operations right here. So let me steal them, and I'll put them here and remove the comments. Okay, and then we can talk about maybe the sequencing of things. Okay, so here we go. Open up the file, read the first line as the number of tests, and then go into a loop 4 times and read the score for each test, keep adding it to the total, and when you're finished, calculate the average and print it out. So let's give it a shot and see. Oh, of course, yes, go ahead and save it. All right. Ooh, okay, we got a couple of things here. What did we do? Total not defined. Okay, well, this type of stuff happens. Oh, right, because I forgot to do total is equal to 0 before I started everything. So here we go, total is equal to 0. Oh, and by the way, if you want to store everything into a list and then process it with a sum, yeah, it works exactly the same. All right, let's give it a shot again. Run, and go for it. Here you go. The average was 90. Now, I guess we'd have to open up the file and double check and make sure it really was 90. But just to show you that this is actually working, let's pop this open. Now, where did it go? Oh, no. Sorry, wrong one. Oh. Okay, fine, I agree to it. No, cancel. Okay, I disagree then. That's the way to get rid of it. Sorry, I meant to open up the test scores. All right, so right now, these are the test scores. Well, let's change it up a little bit. Let's put in a 70, a 70, a 70, a 70, and an 80, because we already know the answer to this. This was 72.5. I will save it. I don't even need to close the window, so I'll just leave it open, as long as you save it, by the way. We go ahead and we run the module, and bang, there he goes to 72.5. I mean, that is really kind of convenient because I don't have to keep typing in the same numbers over and over and over again. So now I'm hoping that what you're looking at this is you're saying, hey, cool, so for the library, I wouldn't need to copy and paste that huge set of books. Instead, I would just read it from a file. And that's exactly what a real system would do. Well, actually, a real system would take the data from a database. But this is like the first step. It's a stepping stone to get there. Okay, so let me see what else I've got here. What am I doing? Okay, 10 out of 15. Okay, yeah, we're actually going pretty good. I think the next few things are just some examples. Oh, and by the way, could I wait until the last second to open the file? Well, you know what? Let's try it. So I can move it around and I can ask whether or not you think it's all right. All right, so there we go. That's obviously not important. Okay, what do you think if I take this and I'll clean up my program, okay, and I'm going to ask you the question, do you think this would work? Why not? Yeah, I opened after I finished doing everything. Yeah, guess what? If you try to read a line on a file that isn't opened, that's not going to work, okay? All right, so that's no good. Oh, let me undo this and then I'll clean this out. Okay, we got a whole bunch of things we have to try. All right, this one I actually don't mind trying. I think this is worthwhile. Okay, what do you think about this one? What type of an error? Where? Why? Okay, first thing you do is you open the file. Next thing you do is you close the file.
You're trying to read from a closed
And you're
file.
trying to read from a file that's closed, yeah. And I have a very good suspicion that that's exactly the error message that pops up. It says IO operation on closed file. Yeah, that makes sense. Yeah, that's pretty reasonable. All right, so obviously you can't close it until you're done. And let's see, what about if I move the close operation to the very end? Yeah, that works perfectly fine. It doesn't really matter. Okay, so here we go. Let's go and let's run it. All right, yeah, score average is still this. And, well, I also said, what about that? I'm opening a file, I'm reading it too, but I never close it. Any issues with this? And the answer is, in most operating systems, no. Now, I have to say that in most operating systems. There are some operating systems where that is an issue. Okay, and this will cause something called memory leaks. And what happens is it slowly burns up all the memory on your computer, makes your computer really slow. I wouldn't worry about it in the world of Python. It becomes really important when you're writing data, and unfortunately I've now gotten rid of my writing information, but I can go and write one back here in a few minutes. Okay, all right, so just a couple of things to talk about. Oh, yes. Yeah. You might have to, yeah. Yeah. Normally I'd stick it into a function as well. Okay, I might say, here's a function, please take this data and write it out in the following format. Okay, so that could happen. All right, new line characters, we've kind of talked about this already. That \n is just a character. If you were able to look inside the hard drive and look at the individual characters, you would actually see something like this, but when you open it up in Notepad or my text editor in a Mac, it ends up it puts things on a different line. But if you were to look with a microscope and see what bits are switched on, you'd actually see the \ns. Okay, so new line characters. So the way how read line works is it reads the data one character at a time until it finds a new line character, and then it says, that's it. That's the way how new line works. And I like to cover this one because it's very, very close to what the input statement looks like. Because think about what the input statement is. The input statement waits, the user types something, and what do they press at the end? Enter key. That's how everything keeps going again. This is why I include the read line character. A lot of people wouldn't include the read line because there might be slightly easier ways to deal with this. Okay, so I still have 2 more examples about reading some data. So I'll have to go over and I'll have to make some modifications. All right, this, by the way, is called a counted loop. Okay, you know how many pieces are coming because you ask the user, well, in this case, we ask the file in advance, how many characters do I have? Or how many test scores do I have? All right, let's change the problem because remember the way how the other one works. The other one, not the opposite of a counted loop, but what's the other style of loop? Sentinel. Okay, the way how Sentinel would work is you would have a bunch of data, and what would you find at the end? Well, something to stop it, like a -1. Not a minus equal 1, but a -1. Okay, that's fine. But you know what? There's actually an easier way. How many test scores are there? No, right now, how many files? How many are there? 10? I don't think there's 10, is there? Yeah, I think I counted 8. I mean, it could have been 10, but I was pretty sure I put in 8. All right, so there are 8 scores. What comes after 6? Well, nothing. It's finished. Oh, yeah, that's right. What comes after 6, 7? In this file, what comes after 6?
Nothing.
Yeah, right, because, what is a joke, because 7, 8, 9. Anyways, no. There's nothing that comes afterwards. That's the end of the file, and if I try to press down, it just doesn't go any further. All right, can we use something like this? And the answer is yes, you can, but it requires a slightly different approach to the programming. As always, because it's a different program. Well, let's try to read this, okay? And I just want to read, and for right now, I'm just going to print each of the scores, okay? I won't do anything else. I mean, we can easily toss it into a list and calculate the average afterwards, but let's just read these in one at a time. Okay, here's what I'm going to do. Come on, here we go. Yeah, almost everything is different. All right, however, the one thing that is definitely in common, I need to do that before I start. Okay, I can't read anything unless I get the file open. All right, so here's what we're going to do is we're now going to go through a bunch of times. For loops are completely inappropriate for Sentinel values because for loops require that you know how many things you're going to go through first. Okay, it's more likely a while loop. Now, I'm going to do something completely crazy. I like doing this. I am going to make an infinite loop. It's another stop. Yeah, when am I going to stop? When I hit the end. So really the question is how do I know I've reached the end? Now there's a bit of a trick here because there's actually one extra line and there's nothing on it. Let me get rid of this, okay? There's nothing now at the end. Okay, so here we go. There's nothing that's highlighting everything. So there is nothing, there's not a blank line. That's kind of, it'll make this a little bit more clear. But let me set up an infinite loop. Here's what we're gonna do. Test score int score data, score file read line print test score. Score file close, because we're supposed to close the file at the end. All right, think it's a good idea to run the program? Okay, people are shaking their head. Good. I like challenges, so yes, I'm going to run it. All right. What would it do? Okay, let's step through it. The very first thing that we did, we opened up a file. Okay, the file exists. That's going to be a whole other pile of problems. We got exception handling kind of later. The file exists to begin with, so that's no issue. That's how we open it. I go into an infinite loop, and what I do is I read the line, I turn it to an integer, and I print it. So in other words, I'm going to see a 70. And then I'm going to read a line again, which is going to be another 70, then another 70, then an 80. But eventually something nasty is going to happen because I'm going to reach 6, and afterwards I'm going to have nothing left. All right, well, as I say, I'm certainly up for running this to find out what happens. Bang, look what happened. it actually did work for the first little while, but eventually it kind of blew up and it said, whoa, no, we've got some kind of a problem here. And yeah, what happens is if you try to read the file and there's nothing there, you get an empty string. Okay, that's what it says right here. It tried to convert that into an integer and it was empty. That's how you know when you've reached the end. Unfortunately, it requires a little bit of rework in order to determine this, because at this point it becomes too late. So here's what I'm going to do. I'm going to remove the typecasting for a second. Yeah.
Can we put a return false?
Something like that. We don't have any returns here, okay? But what we're going to do is if we ever detect an empty string, I'm going to break out of the loop. Okay, so, and that would be the same. So if it isn't a function, yeah, a return would work. Because there was nothing else that came afterwards. So the program has no idea what's going on. It just says, okay, open a file, read a line, print a line, read a line, print a line, read a line, print a line. All right. The only thing that I've done here is I've removed the casting. Okay, so I'm not casting it to an integer any further. Strangely enough, if I run this program right now, okay, so yes, go for it. Take a look at what happens. What happened, I mean, we saw it work, but it just kept on going. Yeah, it's an infinite loop. Okay, it's going to keep on going until when? Well, for the rest of infinity. Sorry, I don't know why Control-C wasn't working, but in any case, let's close that up. Okay, yeah, because it had absolutely no idea when to stop. So when am I supposed to stop? Well, if test score is ever equal to an empty string, that's when I want out. That's how I get out of here. All right, let's save it and let's run it. Oh, sorry, it's gone to a different window. There. So those are all the values. You know something weird about the values? Yeah, why is it double spaced? Well, because remember what read line does. Read line reads the entire thing, including the new line character. So if you don't want the new line character, you have a couple of options. One, there's a nice little program, I saw it on the previous, called rstrip, and what that will do, I think I've covered strip before. It gets rid of the spaces at the end and at the beginning. Rstrip will also include carriage returns and line feeds, which are the things making everything double spaced. The alternative is, what I could do is I could do a casting, because when you cast things into an integer, it also gets rid of it. Okay. All right. So how are we doing? Ooh, sorry, this is going to be a lengthy one. I got to try and finish these ones. All right. So an unknown number of lines. Okay. This is exactly what I've done. I've read the data. And where's the cursor? Here we go. And I said, okay, if the test score is ever equal to a blank, then get myself out. Otherwise, turn the score into an integer and then append it. And once I appended, well, now I'm back to a 1201, well, earlier exercise on processing lists. Okay, some alternatives. Yeah, actually, you can use a for loop, and for loops are really, really clever for this, because on the left-hand side, you can see that I opened up a file, okay, called class data, opened it for reading, and I went through and I said for line in score data, and that also works. This actually makes life a little bit easier. Okay, so this is for once. I mean, hopefully you remember that for loops was a little bit nicer. So for score in score file, print score. All right, take a look at this one. There you go, back again. That's easier than the one I just showed you. But I wanted to show you the one that I had because, well, it was something that was very, very similar to a Sentinel-based loop. Again, we've got the double spacing because it's also including the new line character each time. If you cast it into an integer, it'll be no issue. In fact, since we're here, hey, let's do this. Scores is a big list. Scores append. Score. After I close the file, I'm going to print the scores, and I'm going to ask you to take a look at the result of this, and then we'll fix it. Okay, so there you go. That's all the scores. Oh, but you'll notice something weird about the scores. The scores are strings, and they have a new line character. Okay, well, instead of appending that, why don't you just turn it into an integer? There you go. And that will look after the problem. Okay, there you go. Excellent. All right. On the slides, you may have also seen something that looks even easier. Okay, well, that's a trick. Okay, here we go. Okay, that's not, okay, this is a bit of a trick question. Read line does what? Gets the very next line in the file. Read lines reads a whole bunch of lines. All right, let me show you what it looks like. Hang on, am I running the right thing? Because I shouldn't be. Sorry, I think it's there. Let me close this one, okay, just to make sure I've got the right thing going. Book. All right. All right. Oh, look at that. It automatically put it into a list for us. Unfortunately, it's still a string. It still has new line characters. So it's the data, but the data would need to be processed and turned into integers so we could do calculations and so on. So it's some alternative ways of reading data from the files. It's the right-hand side. It's convenient. However, if it's a really big file, it turns out it's not very efficient. The one on the left-hand side, that is the most common thing that I end up using for reading files. You basically set up a for loop and you read one line at a time and you process it. So what would we end up doing if we were to go back to, sorry, let's go back to here. Sorry, I'm almost finished. Could I do something like this in a file? And yeah, you see my piles of students. What's stopping me from taking the students and putting these students into a file instead of reading it from here? I could just read the file one line at a time and put it into a list. And of course, that's exactly the type of stuff that we're going to do. But we're going to do that next time, because now we have at least the background on how to set up the files for reading and how to write some stuff. Just before you go, and I do have 8 minutes, sorry, I know sometimes this does happen. I will like to do a small, quick little demonstration over here in the online development environment, because, well, you guys know this is the one that you end up getting on the final, obviously the lab exam, no, there's no file stuff. All right, let's repeat the same thing, okay? I'm gonna keep this very, very simple. We need to create some data, so let's put in data, just some test scores like this. Okay, 4 of them will be fine. If I said for score in data print score, okay, that's exactly what we expect. There's nothing weird about this. Let's send it to a file instead. All right, to send it to a file, I need a file variable. So I'll call it the score file. What do you need to do? You need to open. What do you want to call it? Scores.txt. Do we want to open for reading or writing? Yeah, we want to write it because we're going to send it there. Okay. Instead of print score, you'd have to say score file write. But remember, I need to turn it into a string, exactly what we did before. So this is going to be score. And if I want the new line characters, I have to put it in myself. And no choice on this one. And then when we're finished, what do we do with the score file? We close it, so score file.close and print, and I'll just say done. Okay, just so we got something. All right, let's clear the output. Let's run the program. Done. Okay, how do we check the files? Okay, well, it's hidden over here in the file manager. There is one file called scores.txt, and if I take a look at it, there it is. Okay, that's the way how it works. The only thing, this is actually a little bit easier because in a real system you have files and folders and so on. We don't have it, so I've removed that. It's a little bit nicer this way. And there's a place down here, sorry, you can't quite see it because we had a pile of issues with formatting, but you can cancel and save and rename it and so on. Okay, let me delete it. Okay, so it's gone from the file system because I would like to demonstrate this. Okay. Oh, well, I just forgot to close the file. Okay, does it continue to work? Okay, let's clear the program, or clear the output, run the program. Good, it worked. If I go over to the file manager, however, it's there, good. If I open it up, we see it. You have to watch out because there's not a guarantee, there's never a guarantee that you will actually see it here. You might actually still have an empty file. It really depends on the operating system, so please, when you're finished, close the file. And if you forget to close the file in any assessment, I'm going to take marks off for it, and you can't claim, yeah, but it still kind of worked. No, especially in writing, there's a lot of cases where things don't work. I'm actually surprised this ended up functioning today because generally I see it not working. I think if I write out just the right number of things, it's okay, but on the Mac, I know it doesn't always work. On Windows, it tends to work. Just close the file when you're finished. Okay, it's kind of like a doc string. Just put it in anyway. Don't say, well, I could save myself a couple of seconds. Don't fall for that trap. Just close the files when you're finished because there's no guarantee. All right, sorry. There's one extra item, and then I promise I will be finished. That's why I know I said that last time. All right, how many scores are there? 4. Okay. If I run the program again, how many scores will there be? Oh, sorry, let me change the number. Okay, 50. If I run the program again, how many scores will there be? 5. Okay, good. And if I try doing this, this is a problem because I open up the file saying I want to read from it, but instead I'm trying to write to it.
Yeah.
Okay, guess what's going to happen? That's going to be some kind of an error. Not writable, okay? All right, so I got one final letter, then we're done, and I don't have anything else to say today. There's another option called A. A stands for append. So what this means, when you append something, it means keep all the data that used to be there and add some more stuff onto it. Oh, just like an append on a list. Yeah, exactly that. So if I run it again, bang, it says done. If I go to the file manager and I show you what's inside here, you'll see now that there's more stuff. Okay? And if I run it again, yeah, the file keeps getting bigger and bigger and bigger. So if you want to preserve what you've got and just make the file bigger, then you open it up for A. Okay? All right. I don't think I can use any more of your time because I've already gone like 10, 15 minutes beyond what I should. So now I'll stop. Go or I'll keep talking. Yeah.